Okay, this is chapter 21 quiz. The first one, a 5 microfarad capacitor and 7 are connected in series across an 8 volts. So the first one, okay, so this is the C1 equal to 5.0 microfarad. C2 equal to 7.0 microfarad. Okay, let me find black. Okay, and then voltage is 8.0 volts. All right. What is the potential difference across connect in series? So in series, right? In series. Okay. So this is C1 in series C2, right? And then this is 8. All right. So C1, C2, 8.0 volts. All right. So connecting series, looking for voltage. Connecting series, then we know equivalent, so you have to turn that to equivalent. Okay, so 8.0 volts. What is the equivalent capacitance equal to? Okay, so here is 1 over 5 plus 1 over 7. Okay, so this is 35, 5, 7. So this is 35, 12. Okay, so this is equivalent capacitance. Then what is amount of charge? Okay, amount of charge on this one will be Q equal to you see voltage here times C equivalent, right? So it's 8 times 35, 12. Okay, so this is 3, 2. So 70 over 3. So this is the amount of charge. Okay, and this is the amount of charge. And then you go back. So they connect in series. Okay, so amount of charge Q1 equal to Q2 equal to Q because they connect in series, right? So Q1 is 70 over 3, right? All right. So what's the voltage here? Voltage V1 equal to Q1 over C1 equal to 70 over 3. What's the C1? The 5, right? So this will be what? 4 over 3 equal to 4.67. Okay, all right, so it's a 4.7 volts. All right, so that is the first one. All right, second one, when 1.0 meter length of metal wire is connected, okay, so metal wire connected to a 1.5 battery current. Okay, so this length equal to 1.0 meter, and voltage is 1.5 volts. Current, okay, so I equal to 8.0 milliamp. All right, milliamp is 10 to the 8, 10 to the negative 3 amp. All right, flow through it. What is the diameter of the wire? All right, so here is, and also you know resistivity. Resistivity is 2.24 times 10 to the power of negative 8 ohm meter. Okay. So first we have to see what is the resistance of the wire. Resistance equal to voltage over current, right? So equal to, okay, so let's see. Let's do this, okay? So resistance equal to voltage over current, also equal to resistivity times length over area. Okay, so area is, because this is a wire, metal wire, okay, area is pi, asking for diameter, right? So d over 2 square. So for the circle, area is pi r square, also equal to pi d over 2 square. Okay, so from this equation, you see v over I equal to this. Looking for diameter, right? So let's make a little bit. So equal to this, right? Equal to rho L pi d over 2 square, right? So everything else we know, looking for d, right? So what we do here is d over 2 square equal to rho L over pi, right? And then times current divided by voltage, all right? So what is d here? First you do square root, right? d over 2 equal to square root rho Li pi v, and then d equal to, you see, times 2 here, all right? So you plug in everything, right? So rho is 2.24 times 10 to the negative 8, okay? L, 1 meter, current, 8 times 10 to the negative 3, the current, right? So pi, voltage is 1.5. Okay, so just use a calculator, so that will be the answer. Okay, calculate it out. Number 3. All right, 4 resistors having resistance 20, 40, 60, 80 are connected in series, right? So this is resistor 1, 2, 3, 4, right? In series across an ideal DC voltage. If the current flow through is, okay, so current flow through 0.5 ohm, half amp. What is the voltage of the voltage source? So this will be 20, 40, 60, okay, so those are ohm. 80 ohm, okay, so connected with a voltage source. We don't know. And looking for EMF. Well, the key for solving this kind of problem is you can, make that into a simple circuits like that. You see, EMF, right? So what is equivalent resistance? You see, connect together in series. This is resistors, right? Equal to 20 plus 40 plus 60 plus 80. This equal to 200 ohm, right? And then the current here is 0.5A, right? So what is EMF? You see this simple circuit, you know EMF equal to current times resistance, right? So it's a 0.5 times 200, okay? 100 volts, all right? Number 3. Number 4. The resistivity of a gold is, okay, so resistivity of the gold equal to 2.44 times 10 to the power of negative 8 ohm meter, okay? At a temperature 20 degree, okay, so T equal to 20 degree, okay? A gold wire 1.8 millimeter, so D equal to 1.8 millimeter, okay, so this equal to 1.8 times 10 to the negative 3 meter, you have to turn to meter. And 14 centimeter long, L equal to 14 centimeter equal to 0.14 meter. Carries a current, okay, so current equal to 480 milliamp equal to 0.48 amp. What power is dissipated in this wire? Okay, so here, looking for power, P equal to, okay, so you know current, right? Equal to Ri square. Okay, so if you know current, and then you're looking for resistance, all right? So what is resistance? If resistance equal to rho L A, right? A is a pi d over 2 square. Okay, so this is A. Then times I square. Okay, so here everything's known, right? So looking for, so this is 2.24 times 10 to the power of negative 8. L, 0.14 pi d 1.8 times 10 to the negative 3 divided by 2 square, right? And then times current square. Current is 0.48 square. Okay, so that's the power. Just calculate this out. Use your calculator. So in this part of physics, you got to be really familiar with your calculator. Quickly punch this one and get an answer. All right, 5, 4 unequal resistors are connected in parallel. 4 of them in parallel, right? So like this. No, this is a capacitor. 1, 2, 3, 4, right? In parallel. Okay, so that's meaning in parallel. Which of the following statement is correct about this combination? Okay, in parallel, right? Which means equivalent resistance equal to 1 over, you see, R1, R2, right, add together. Okay, which means you make your equivalent resistance smaller. And the voltage on everybody is the same. Okay, so V is the same. V1 equal to V2 equal to V3 equal to V4, and the current add on. Okay, so that's the relationship. The equivalent resistance is middle way between, no. B, the equivalent resistance is less than that of the small. Okay, so B actually is right. Okay, but let's see. C, the equivalent resistance is equal to the average, no. D, the average resistance is more than, no. Okay, so B. Number 6. 5 microfarad, 14 and 21 capacitor connect in parallel. Okay, so now in parallel. Okay, so in parallel, voltage the same, charge add on. Okay, how much capacitor would be a single capacitor need to have to replace? Okay, all right, in parallel, right? In parallel means capacitance. Well, if you simplify that, right? So this. Okay, in parallel, they actually add on. That is the capacitance, right? So be 5, 14, 21. Add them together. So equivalent capacitance, the 5 plus 14 plus 21. All right, 35, 40. Okay, so I be 40. And remember, capacitance and resistance totally different. The opposite, actually. 7. All right. A simple circuit has a total resistance 30 ohm. If a 2.0 current is maintained in its circuit, how much energy is dissipated in this circuit? 4 seconds. All right. So we know power equal to, you see, if we know current, and the resistance equal to I squared times R. That is power. And energy dissipate, right? Energy equal to power times time, right? So equal to time, add all together, right? So put all together, so that will be 2 squared, and this is a 30. Time is 4 seconds. Okay, that's it, right? So 4, 16, 480, right? Unit here is joule. All right. Next one. Next one is number 8. Okay. 3 capacitors of equal capacitance arranged shown in the figure with a voltage across the combination. Okay, so if the voltage drop across C1, so you have equal, right? So same kind of capacitor, C1, C2, okay, C3, C1, C2, C3, and you have voltage drop, voltage here, okay? All right. If you know C1 is 10, so here is 10 volts, and C1 and C2 connected in series. In series means amount of charge is the same, right? Amount of charge is same, and C1, so equal capacitance, C1 equal to C2 equal to C3. All right, so if here 10 volts, then here must be 10 volts because amount of charge on C1 will be 10 C. So let's make all of them equal C, right? 10 C. 10 times C, voltage times capacitance. And so for voltage at 2, V2 equal to charge is the same, right? So 10 amount of charge here, so Q1 equal to Q2, right? Equal to, you see, 10C, right? So V2 equal to Q2 over C2. C2 is C, you see? So here is 10 volts. So 10 volts there, 10 volts here. Okay, and then the voltage from here to here is 20, right? So 20 here, so it'll be 20 there because this part and this one connect in parallel. Parallel means voltage same. Okay, so 20 volts. 20 volts. The question here is what is the voltage drop across C3? 20 volts. All right. Number 9. Number 9, 400 watt computer, including its monitor, is turned on for 8 hours. Okay, so T equal to 8 hour. 8 hour actually is, I just like to use hour for the time being. If electricity costs 10 cents per kilowatt hour, how much does it cost to turn the computer annually for 365 days? Okay, oh, that's a lot, right? So we know the power here is 400 watt, all right? So we know, first you calculate energy, right? Energy here is power times time, right? So power is 400. Time here is 365 days, right? A day, 24 hours. This is total energy. So in the unit of watt, right? This is watt, and here is 365 days and 20 what day or 24 hours. So this is a watt hour. Okay, and you charge for 10 cents per kilowatt hours. Let's see how many kilowatt hours. So if you divide by here by 1,000, right? So equal to 400, 365, 24 divided by 1,000. That will be kilowatt hour, right? And then 10 cents per kilowatt hour. So cost equal to whatever this number times U times the rate, right? It's the rate. So times whatever is number times 10 cents. Okay, so let's see. So basically is 0.4, 365, 24, and then times 10 cents, it will be $0.1. Okay, so this is how much dollar. Okay. Let me take a guess, right? 24, so it's about 700. Okay, so this is the 0.4, 0.04. Wow, not a whole lot, right? So it's about, well, let's see. Let me use the calculator. 0.4. 0.4 times 365 times 24 times 0.1. Okay. Oh. 400 watt, 365 days. Oh, no, I'm sorry, 8 hours a day. Okay, so let's see. 8 hours a day. So not 24, it's 8 hours a day. Because you only on for 8 hours, right? Okay, so then we go this one. Okay. Yeah. So it's about, the answer here is 116. Okay, so instead of 24, it should be 8. You only run 8 hours a day, and for 365 days. Okay. So my answer is $116.48. So this is about 120. So that's roughly. So when you do multiple choice, you're looking for the closest answer. All right. Number 10. All right. In the circuit show, okay, so here's the circuit, right? So you see you have V1 is 3.0 volts, okay, and then you have R1, R2, right? R1 is 60 ohm, okay, R2 is 120 ohm, and then you have R3 is 180 ohm, and then you have V2. Okay, so V2 is 6.0 volts. All right. So this is the circuits, and what is the current through R1? So looking for R1, right? Current through R1. So this is a 60 volts, right? Okay, so this is a multi EMF circuits. We have to use Kirchhoff's rules, right? Okay, so you see how many branches. So this is a branch, right? Branch, you have 4 branches, right? So let's make a current, right? So consider this is R1, R2, I3, okay? And let's make this I4. You see, you have 4 branches, right? 4 branches. You're looking for what is I1, all right? So you have 4 branches, right? So if you write out you see every branch you have a current. So let's see what is your so you see this is one junction, right? This is another junction, so you only have one junction function. Junction function here is flow in, flow out, right? Together is 0, so flow in, I1 flow in, I2 flow in, I3 flow in, I4 flow out is 0. Okay, this is junction function. Then we look at loop, right? So this is one loop, second, 3 loop, right? So this is a loop 1, loop 2, loop 3. All right, let's see loop 1. Loop 1 here, let's start from here, right? So go this way, so clockwise, right? Okay, clockwise, right? So 3.0, right? Then you get here, you see you get here, right? 60 ohm, loop direction, current direction in opposite. Opposite will be plus 60 I1 is 0. So this one give you I1. Directly you figure out I1 equal to 3 over 60 equal to 0.05 amp. Actually is it is a negative, right? Negative. What does it mean? Which means we assume this is the direction up, right? Actually they will be down. So current direction here is down. Okay, so I1 will be 0.05 amps and flow down. Okay, you actually just one equation, you already solved that. Well, what is I2? Same thing here, right? You see 3.0, same thing here, minus plus, still plus, right? Current direction, current loop direction, you see loop direction is same, right? Opposite. Okay, let's see. Okay, let's redo the circuits, right? So this one, actually I should do this way. Just make a little bit clear. All right. Okay, so this is 3, positive, negative, 3 volts, 60 volts, 180 ohm, 120 ohm, and this is the 60 ohm, right? So I consider this is I1, I2, right? I3, so that's all my I4. And looking for I1, and I use this loop. Just one loop, we figure out I1, okay? Same thing here, you can figure out I2. I2, it's a convenient one is use this loop. So you start from here, go here, and then come down. Use this loop. As long as it's a closed loop, it works. So you can figure out I2, right? And then if you know I1 and I2, right, then you can use this loop, right? Okay, because you know I2, because it's one equation you already know I1 and also you know I2, similar thing, right? And then you can figure out I4. So this circuit is very simple to solve. Okay, all right. So that's all for this quiz.